So people worry about cholesterol. The word just sends shudders down everyone, and it's wrong. I mean, cholesterol is a Greek word, Greek, and it means chole means bile and sterol means solidity. And it tells you what its natural role is. And normally it's a powder, a solid powder. So the chole part, we make bile salts out of cholesterol to help digestion. Without cholesterol, we wouldn't be able to absorb fat using the bile in our intestines. So cholesterol and bile are essential. Cholesterol is in every cellular membrane. All of our cells have cholesterol in the membrane. Without it, frankly, they'd fall apart. It gives solidity to the cell. So again, cholesterol is essential. Cholesterol is the precursor molecule for vitamin D. The sunlight wouldn't do anything unless we had the cholesterol to start off with. And all of the steroid hormones, testosterone and estrogen, are made from cholesterol. So cholesterol is not something damaging and foreign. It's actually a good thing to have, and you'd be very sick without it. And we make 85% of the cholesterol in our body, our liver does, and the diet's only a top-up. And so the idea of cholesterol in the diet being harmful has really died over the last few years. It started off with this Russian who fed cholesterol to rabbits, and he found cholesterol-rich plaques in their blood vessels. And people thought, oh, eating cholesterol must be bad. But even he in that first paper said it causes the problems in rabbits but not in rats. And therefore, I'm not sure whether these experiments that I've done have any relevance at all to human pathology. So all that stuff about eating cholesterol for animals has really got no relationship to humans. And even Ancel, who put the cloud over cholesterol, said himself that the cholesterol in the diet doesn't matter. It's more the other things in the diet that matter. And this was Ancel graphs, which many of you will be aware of. But the higher your cholesterol, the more likely you are to have heart disease. Or the higher your saturated fat intake, the more likely you are to have heart disease. Now, many of you know how biased those studies were, because in modern times, people have done the same sort of studies and found completely the opposite. The lower your cholesterol is, the more likely you are to die, and the higher your saturated fat intake is, the less likely you are to die. So how do we explain such conflicting data? And the issue is because it really has very little to do with cholesterol itself. You need to understand how cholesterol relates to the real pathology. You need to understand that cholesterol exists in particles we measure in our laboratory in the blood. And the important particles are these VLDL, IDL and LDL particles, which we'll go through what they mean. So the liver makes the VLDL particle, the big particle, and it's full of triglyceride and fat. And then that particle floats around in the blood, and gradually the triglycerides are taken out of it, hopefully to muscle, but maybe to adipose tissue and other tissues. And then they get smaller and smaller until what you're left with is a cholesterol-rich, smaller particle called LDL. So this is triglyceride-rich and this is cholesterol-rich. Now what normally happens to LDL, once it's finished playing this game, is it goes straight back to the liver. Now, one of the things that does happen in nature is if you've got an abnormality where the liver won't take up that LDL because you've got a genetic abnormality in the LDL. It's rare, it's about 1 in 10,000 of the population. But if you do that, well then the LDL is going to accumulate in the blood. Normally it shouldn't accumulate. The things that control that receptor for LDL are 3 parts. There's a protein around LDL called Apo B. There's a protein on the liver cell called the LDL receptor. And there's another new protein we found which is a regulator of that reaction. So abnormalities in any of these three may change the way the liver handles LDL. So in this paper from 40 years ago, they looked at those patients with an abnormality in the LDL receptor, and what they found was that normally the LDL disappears over a week or two. It stays in the blood for a while, but it takes a week or two to disappear. But if you've got an abnormal receptor, it hangs around twice as much or twice as long, whichever way you want to. So now LDL that hangs around. And that's what happens in diabetes as well. Normally the LDL goes straight back to the liver and disappears in a week or two. It's done its job in a week or two. But in diabetes, it hangs around. Now, in many of my other talks, I've showed you this relationship because this is really important. So if we have fructose, just refer to the other talks, you end up with fat in the liver, triglycerides, and they're exported as that big particle, VLDL. The VLDL can interact with HDL through this cholesterol ester transport protein, and in this process of giving up triglyceride and taking up cholesterol, what happens is you wear out your HDL. So any patient with a high triglyceride and a high VLDL being made by the liver is going to wear out their HDL. So high triglycerides always result in lower HDL. That's one problem. The other problem is that high triglycerides interact with that LDL. So that LDL that might be hanging around because you're diabetic and you've got high triglycerides has got a real big chance of reacting between these molecules. And what happens here is triglycerides go in, cholesterol ester goes out, and in this process what happens is the LDL doesn't disappear, it just becomes small and hard. So this relationship between high triglycerides or VLDL and the long dwell time of LDL in the blood is what leads to it being small and dense. And how important is it? Well, the small dense LDL, well, first of all, look at the normal LDL. This is normal big buoyant LDL. If you have increasing levels of big buoyant LDL, your risk of heart disease doesn't change. It may even improve. Whereas if you've got increasing levels of small dense LDL, your risk of heart disease is increasing threefold, 3 to 4-fold. So it's not LDL that causes heart disease, it's small dense LDL, purely small dense LDL. Now, we mentioned those patients that might have an abnormality in the LDL receptor, familial hypercholesterolemics. So they've got all this LDL that's hanging around and it's accumulating in the tissues, whether that's the eyes or the Achilles tendon and so on, or in the blood vessels. But what sort of LDL is it in familial hypercholesterolemia? Because we've just said large buoyant LDL is safe and small dense LDL isn't. And when people look at patients with familial hypercholesterolemia, the LDL they have in these green bars here is LDL 3, 4 and 5, which is small dense LDL. So FH isn't a disease of high cholesterol or high LDL, it's a disease of high small dense LDL because the LDL is hanging around long enough for it to become small and dense. Now, giving a statin to a patient with familial hypercholesterolemia improves their outcome. There's no doubt. Anybody with familial hypercholesterolemia should be thinking of a statin therapy because it improves outcome. But how does the statin improve outcome? It reduces LDL, but what it particularly reduces is small dense LDL. So the reason why statins work in familial hypercholesterolemia is that they reduce the small dense LDL. They don't eliminate it completely, but they reduce it. Remember, the risk of death didn't disappear completely, it was just reduced. So ideally we'd want to get rid of it completely. So the small dense LDL, why is it so harmful? Well, the simple idea is it's smaller and it can get into the blood vessel walls and form that plaque, that obstruction. And more than that, people think that once it gets into the blood vessel wall, it can be changed by glycation or oxidation, and then this really rubbishy small LDL is taken up by the scavengers of the body, which are the macrophages. And if you've got lots of it, those scavengers become engorged on this rubbishy LDL. And that's what plaque is. So look back on that diagram, VLDL becomes smaller, and this stuff should go back. But if you've got the capacity to make small LDL, which becomes glycated and oxidized, it starts accumulating in the cells of the blood vessel wall. And here's just some papers, you don't need to remember too much other than when you oxidize LDL, macrophages go crazy. They start talking to other macrophages and say, let's do something more. And what about glycating LDL? What about sticking sugar onto LDL? What would that do? We know that sticking sugar onto hemoglobin is related to the risk of heart disease. And similarly, people have shown that if you put sugar onto LDL, again, the macrophages go crazy for it. And you'll accumulate that in the blood vessel wall. So the way you should think of LDL is normally it's green and good. If triglycerides are present, it'll become small and dense. And if it's small and dense and gets into the blood vessel wall, it can be glycated and oxidized, and that's where the trouble starts. Now, we can measure small dense LDL in one laboratory in Sydney's been doing it for 10 years. I think there's another lab started up in Melbourne recently. And this is the LDL area. And so ideally you want this sort of LDL, the large buoyant LDL, the green stuff. But if you've got this stuff here, that's small dense LDL. So the more red you have, the more we know you've got this risk of an atherogenic form of cholesterol. Recently I was in Cyprus and I was really surprised that a little laboratory in Nicosia was doing small dense LDL sizing. Cyprus is tiny compared to Australia. But I wasn't surprised that if somebody was offering such a test, the most important person in Cyprus gets his blood tested there. So cholesterol does correlate with LDL. Generally, if you've got a high cholesterol, you've got a high LDL. But we're not interested in whether you've got a high LDL. We're interested in whether you've got a small dense LDL. And the relationship between cholesterol and small dense LDL is very poor. You could have a cholesterol of 8 with virtually no small dense LDL, or a cholesterol of 8 with 30% of it as small dense LDL. Now, you can do that test, or otherwise you can predict whether you've got small dense LDL from your triglyceride level. And if your triglyceride level's below 1, as most LCHF people are, they don't have any small dense LDL. Whereas once your triglycerides are over 1.5, which 30 to 40% of Australians are, you've got small dense LDL and you're in trouble. That was 1990. Here's another study from 2001. When you're over 1.2, your small dense LDL concentrations start to rise. And here's a more recent study, 2015, in patients with pre-diabetes. Once you're above about 1.1, the likelihood of small dense LDL rises. So that's a really hard target. Now triglycerides are a pretty good predictor of small dense LDL, but there are better predictors. And the ratios seem to predict it even better. So the ratio of LDL to HDL or total cholesterol to HDL, for some reason, predicted even better. Here's a recent study that looks at the ratio of triglyceride to HDL as the best predictor of obstructed blood vessels. So why does this ratio to HDL work better than triglycerides if Ken's just told you that triglycerides are the be-all and end-all? Well, it's a mathematical issue. Triglycerides are highly variable from one day to another. And statistically, they're not an even distribution. You can sort of jump out and jump back. And so, whereas HDL is more stable, so in a way the HDL is a better statistical marker for high triglycerides than triglycerides are. But the effective treatments should decrease triglycerides, and if you decrease triglycerides, you should decrease your small dense LDL. And so here are the carbohydrate restriction studies from Volek and co, where they show that the severe restriction of carbohydrates results in the greatest reduction of triglycerides and the greatest improvement in HDL. And another review by Ron Krauss showing that the lower you can get your carbohydrate intake, the lower the likelihood of having small dense LDL. So just a summary of that part, cholesterol is good. So cholesterol itself is not a reason to worry. LDL is normally good. LDL on its own is not reason to worry. But modified LDL is bad, whether that's small or dense or glycated or oxidized. Now before I want to finish, there are other ways we can modify LDL. And one is this protein called lipoprotein a. And it's a form of LDL which has got this long tail wrapped around it called Apo a. It's LDL with a tail on it. Once it gets that tail on it, it tends to hang around in the blood longer. I don't know whether it becomes small and dense because of that, but we do know that Lp(a), the higher Lp(a) is, the more likely we are to have a cardiovascular event. Now, Lp(a) is very difficult to change. We don't have medication that can change it. I'm not sure what LCHF diets do to it. And there are some patients, about 1/3 of the patients, who have this exaggerated rise of cholesterol on LCHF. They've got Lp(a) present. And so we need to have a close look at those patients. So that's the first test I do if people get an exaggerated response of cholesterol on LCHF, is to check the Lp(a), because it may be a different form of LDL that's accumulating rather than small dense and so on. Now the other thing which is quite interesting and exciting is that third protein in the LDL receptor called PCSK9. What normally happens is LDL combines to the receptor on the hepatocyte, and then it's taken in by the cell and taken in and destroyed, if you like. But the LDL receptor goes back out to catch some more LDL and bring it back. You know, we want to bring it all back after a week or two. But what PCSK9 does is it tags LDL and the receptor and says, when you absorb it, destroy the LDL and destroy the receptor as well. Now that's a bit harmful, because if you lose all your receptors, the LDL is not going to be able to come back easily. So patients with high levels of PCSK9 have high levels of cholesterol. So here's this graph about PCSK9 levels in blood vary from about 100 to 500, huge variations across the population, and the level largely determines how much LDL you've got in your blood. But more importantly, if you're taking off your receptors and the LDL's hanging around in the blood, it's going to become small and dense. So again, I imagine that many patients, it's about 5% of patients on LCHF have this exaggerated response to the LCHF diet. And I think that this explains some of them as well. And we need to know, the important thing is it's small and dense, because these PCSK9 polymorphism can cause small dense LDL as well. And we don't know what prevalence it is in the population, let alone amongst LCHFs. So, when should we worry about cholesterol? We shouldn't worry about cholesterol, we should only worry about whether we've got modified LDL. We know how to reduce most of those forms. We can get rid of small dense LDL, glycated LDL, and probably oxidized LDL by just going to LCHF diets. We need to learn a bit more about what Lp(a) and PCSK9 does on LCHF diets. It may not be harmful. I suspect it isn't, but we need to understand it more. And maybe my next lecture will cover that. Thanks very much.